Hello guys, welcome to the video, and today we'll discuss about seismic analysis of structures. It can be broadly divided into two types: linear analysis and non-linear analysis. In linear analysis, we consider various properties like stiffness, modulus of elasticity, moment of inertia, sectional area, or shear modulus as constant. Whereas in non-linear analysis, we consider them varying during the load application. If we draw a graph of action versus deformation, for linear analysis, it will be like a straight line. Okay, and actions may be like force or moment, and the deformations may be displacement in terms of angular or linear displacement. Okay, it will be a straight line, and force will be directly proportional to displacement, which means that it follows Hooke's law. Whereas in real life, the graph will not look like that, because the structures and members are non-linear in real life. That's why it will be linear for some part, and it will be curved like this. Okay, and this is the actual curve, and non-linear analysis is extremely tedious and complicated. That's why we must use linear analysis. But because of the linearity and constant slope, it will give some deformation during any kind of load. That's why it has some limitation, like if we apply unrealistic load, which might be extremely high, then it will give some deformation that are unreasonable and extremely high. That's why we have to manually analyze that it has failed if we apply unrealistic load, and if the material has failed, it will never predict material failure and element failure. That's why non-linear analysis is the most accurate one for carrying out seismic analysis, but because of its complicated, it is really difficult to use. If we have to use non-linear analysis, then we have to first carry out linear analysis, and then we find out the required cross section, and based on that we draw a graph like this, and we give this as input for nonlinear analysis to the software, and by this we can closely approximate the behavior of structures during seismic loading. Okay, further linear and nonlinear analysis can be divided as static and dynamic analysis. Okay, there are various common seismic analysis methods. For linear static analysis, we can use lateral force method, and for linear dynamic analysis, we can use response spectrum analysis or time history analysis. Time history analysis may be carried out by using direct integration or modal response method. For nonlinear static analysis, we can use various pushover analysis methods, and for nonlinear dynamic analysis, we can use nonlinear time history analysis. For seismic design of structures, there are various codes that guides us to design them, and some of the main design procedure includes lateral force method, response spectrum analysis, and time history analysis. Mostly we use lateral force method because of its simplicity, and it is used for regular and ordinary buildings. But for irregular and important buildings, we have to use response spectrum analysis or time history analysis. And also for Buildings in which the deformation or seismic response is not dominated by the fundamental vibration mode, then we have to use these two methods. Okay, and mostly code as not explicitly mentioned, we have to use these two because of its complexities, but we have to follow lateral force method. And in code, as we consider mostly linear analysis, for economic consideration we have to reduce force, and we use various factors like response modification factor. Building code does not explicitly mention to carry out nonlinear analysis. Rather, they suggest us that we have to modify by using such factors. Because if we draw curve for linear analysis, it will be like this, but in reality, the curve should be like this. Okay, and for a large load, for deformation and for the same deformation, if we draw the line, then we can clearly see that there will be certain extra forces included in linear analysis. That's why we take some response reduction factor to account for non-linearity of structures. Okay, this was for this video, and in the next video we'll be talking about various analysis techniques in detail and the way of designing the structures by using those techniques. Thank you for watching. Stay tuned for the next video.